Okay, so the 15th problem in Leet Code is threesome. Okay, so basically what we need to do here is we'll be given a list of integers. Okay, so we'll have to find a triplets here such that the sum of the triplets should be equal to 0. Okay, that is a condition, and the second condition is it should be distinct basically. Okay, so what it means is, let's say that -1 2. Okay, it will result in the sum of 0. So it can be rearranged, right? It can be written like 2 -1 -1, correct? That will also result in 0, correct? And so that's what actually, like, it should be distinct. Okay, and that is the main condition, and the sum should be equal to 0. These are the two conditions we need to be taken care. Okay, and now coming back to the implementation, right? Before actually jumping, so or to give an overview, right, what is the logic that can be used here, that is used here is, let's say that I want to find a threesome. Okay, so basically it is like a plus b plus c is equal to 0. Okay, looks like it. Okay, now let's say that I know a. Let's say that when I'm doing a calculation, I will say this is an a. So if I know this, now I will have to find just this, correct? Like, I mean, it will be like b plus c is equal to minus a, correct? Similarly, if I again fix the b, again what will happen is b is equal to minus a minus c, correct? That is a logic that is being used here. So first, just directly, not, it's a two pointer method actually used here, but before that I will just show the my whole code. Okay, so what was being done here is, let's say that we need to send back the result in one combinations, right? So it, and also we don't want to rely on any index here, correct? We just want a value, so sorting will not affect our final output, correct? So what we'll do is we'll do the sorting so that it will be helpful to check for us to if we are not duplicating the, if we are getting the distinct triplets or not. Okay, so now coming back to the solution, we'll set our result as empty, we'll find the length, and we'll now sort it also. And here what we'll do is we'll fix the first value. As said, we'll iterating, right? We use, this is the O of n square complexity one, and we'll fix the first value. Now what we are left with is we'll have to find a second value and third value from this value. Okay, so we have fixed it here, and now we'll iterate through this list. Okay, and when we are iterating through it, we'll fix the second value as this. Okay, and then we'll fix as this. Similarly, we'll proceed. Okay, in this list I will fix this number as a second value. Now what I am left with is, I know the first value, I know the second value, I can easily find the third value, correct? So -1 plus 0 plus z is equal to 0, I can find a z, right? If I add a 1 to this, it will become a 0, correct? So what I will do next thing is I will check if 1 exists in this list. Okay, like whatever the subarray exists, right? I will check if 1 is existing. If exist, it means that okay, there is a triplet. So I will return -1 first value, second value, and whatever the third value we identify here. So that's what the calculation here. And we found the first value in the first main index, and we are running in the subarray. We'll fixing the second value, and we'll finding the third value also, and then we'll check if third value exists or not. If it exists, then append it to the result. Okay, this is what it's about. And it was like, I mean, out of 313 test cases, like 5 of them were failing due to the time complexity. So I was just commented this out. So then after exploring the online, like, got to know that we can use the two pointer approach here, right? Whenever, what is that one thing that I learned is, mostly like whenever we do the sorting, right? Sorting is okay on the provided input, and if the sorting does not affect the output, right? So in that case, mostly we'll have to stick around with the two pointer approach, but it's not always true, but we'll have to see like if the two pointer approach is applicable here or not. Okay, similarly we'll do the same thing here. So we'll be iterating through the first iterating, and we'll set our first value as first value. Okay, like whatever we write, we'll fix this as a first value, and maybe whenever we come to the next value, we'll fix that as a first value and do the rest of the calculation. Okay, now what are we doing? So when we in the first iteration, we'll set this as our main value, and here we'll get a next one, correct? So we'll set this as a left pointer and this as a right pointer. And also, this is not the exact array because we will be sorting it, right? It will be like in a -4 -1 -1 0 1 2. This will be the array, correct? So now what we'll do is, now we got the array, right? So we have, let's say that we are our main value here, and we'll set this to the left pointer and this to the right pointer. Now as we keep progressing, we'll just check the sum of these two, minus 4 and 0. It will it, this is the first value, this is the second value, left pointer value, right pointer value, take the sum. If it is equal to 0, yes. If it is 0, then okay, add it to the result, then increment the left pointer, decrement the right pointer, then take a sum. If it is again equal to 0, then go to the next. Okay, this is what we have to do. Like, yeah, if it is, we have fixed the main value, first value, we'll set the left and right pointers here, and we'll check the total. If the total is 0, we'll come back to this later. Okay, like we'll increment it and decrement it. Now let's say that we got a negative number. So, okay, like let's say that we took a sum of the three numbers, but it is resulting in a negative. So let's say it is minus 4. Okay, and also we have sorted in a ascending order, correct? It will be like minus 1, minus 2, minus 1, 0, 1, 2, 3, like that, right? So let's say that we are getting a negative value. If we are getting a negative value, let's minus 5. Okay, if I add some positive, if I add some value to it, it will go towards 0, right? So meaning I want a number to, like, I mean, more than what we have currently, whatever we have, right? That is constituting to minus 5. If I get a number which is already we are having some set of number, right? XYZ. If I get some bigger number, I might go to the nearest value 0, right? I might go to 0. So what we'll do is, we'll increment the left pointer instead of decrementing this. So if we increment this, right, initially, as I said, it will be like minus 4, minus 1, minus 1, 0, 1, 2, correct? If I increment a left pointer, it is obvious that I am going for a higher number. Now the result might go positive. Like, let's say if it was a minus 1, I might go to 0 or even behind that. But if we on incrementing itself, we will be going closer to that, right? So that is the reason we'll be incrementing our left pointer. Similarly, when we are going to the right number, let's say that if it is value is more than 0, right? If it is a positive, so in that case, what we'll have to do, we'll have to pick a lesser number, correct? And again, as the array is sorted, we can just decrement our right pointer, so such that we'll be picking our right element, the least one compared to the less one compared to the previous. Okay, that is the calculation here. And similarly, in between, you can see these checks, right? To avoid a duplicate numbers, we have these checks, actually, basically this and this. So how does that work is, let's say that if you have a these duplicate numbers, right? Let's say that I am here. Okay, I've already done a calculation for it. I've set this as a first value and done a calculation. I don't have to set this as again the first value and do the calculation, right? Because it will again result in the same values. So what we'll have to do is, we'll have to skip it, basically. So if you go here, so what will, that is it about, like, if it is the only first value, if it is not a first value, from the second number, check if it is the previous value same. If it is same, just continue. Similarly here, we'll check that if the next number and current number is same or not. Okay, similarly to the right. And also here, right, whenever we are doing this calculation, after this calculation will be, our pointer would be still here, like, I mean, we'll be locating to this point. We'll have to increment to this at the end. So this we should not forget. Yeah, that is it. Yeah, thanks.